Yo, what is up? Another stream and another video. Very endless. I've been watching videos for more than 20 hours, or I don't know how many hours. And they are still available, which is good. Because otherwise I'd have to use my S Pen. But anyways, perhaps we'll get to that. So anyways, the exercise has been solved up until here. I'm going to continue from now. We have the same exponent, so we're just going to work with the powers. So it's going to be 2x minus 6 equal with x. So we're going to find out what is x based on that, and that is it. There should be no DVA crap, and so we have 6 in the result, right? And that's how it's written out. Now we have a matrix combined with imaginary numbers problem right here. Okay, so we know that I of second power is -1 is written here, but I already know that. So you have to understand what complex number z fits here, so that this matrix is 0. Z is just a plus bi. So there are multiple methods here, but I would just make the z, swap it with a plus bi and work like that, and just work with matrix diagonally multiply minus the other diagonal. You're just gonna see it right here. Okay, so diagonal like that. And he actually will not swap a plus bi just now. Perhaps he's going to do that later. That is also a variant, so we're just going to multiply right here. And we'll get this right here. And I to the second power is -1, right? So I think we can write down the I to the third power, just I, and then swap the sign. I think that is possible, but we're gonna see how we proceed here. Yeah, so this is the thought process of how you just swap the sign and make it an I instead of just the I to the third power. So actually you don't need to swap the sign, you just pop it as -I right here, and that minus of that minus is going to be a plus right there. So this is what we have, and let's see what is next up on the solving. Equal of 0, right? All of that must be equal of 0. And now what? Yes, a plus bi, so we're just gonna swap that in, right? So that is being swapped in. And -4, the I is multiplied with each term right there, so we'll have ai plus b out of second power. Once again, we change the sign and remove I to second power. We work with imaginary and non-imaginary, and basically we'll get a and b, and we'll get the z number right down like that. ai plus b out of second power right there. So write that down. But it has been removed and the sign has been changed, so shortcut right there. And now we can just work with this. So the real part without the I equal of 0, and then we're just going to write down the same thing the imaginary part, but we're not going to actually write down the I. That is equal of 0. So we're going to work with a number. So right there we can write down a minus 4 equal to b, and a is going to be equal with b divided by -4, stuff like that. So we're just going to swap that in. Hold up, it's minus, it's not a, it's actually not division, so just plus right there, so that's correct. and we're just gonna swap it in with a. We're gonna get 2b plus 4 equal to 0, so 2b is equal with minus 4, and b is gonna be equal with minus 2, right? And then we're just gonna swap it into a, and it's gonna be 2. So we're just gonna write down the number, which is gonna be z equal with 2 plus 2i, and here it is. Write down the z number in the response. This is the form a plus bi. Actually, 2 minus 2i, right? I think I said something about that, and that's done. So now with a sign and stuff, so I'm just gonna remove that. Here are all the formulas that are provided here, quite a lot of formulas, but anyways, I don't really need them right now. So just move out from here. I'm just gonna skip this trigonometry because I don't really need it. So he really will solve the trigonometry. Like, come on. Alright. Remove. See how long it takes. What, are we gonna solve now? Exercise 9 or what? So write down formula from the end, and basically we have this geometrical progression. b6 is 5, b9 is minus 40. So you gotta find the ratio. Basically here the ratio, it's a constant number that makes the terms change. So b6 is that formula, and b9 is that formula. So I think based on that we're gonna equal the formula with values, and we're gonna find out what the ratio is. Like if I do a system or something like that, this should be possible. Alright, so we have b9 divided by b6 equal with, so this is how it's done here. I mean, I guess I could just count stuff like I think the ratio is minus 15, right? But anyways, I think you need to write it down right like this. So b6 divided by that, so that will be what, minus 8. So if you write down formula like that, that is simplified. So ratio 8 on ratio 5 as that, and that's formula right there. So we can work like that, and ratio third power is minus 8, and this means that the ratio is 2 minus 2. Why minus 2? How does that make sense? Like, come on, how is it minus 2? You're putting it a power of minus 2, or watch how to get that number. Anyways, that's that. Now he's gonna try to solve exercise 10. I'm gonna skip that. Skip a bit. This is geometry stuff, which we can also skip. This geometry problem, I don't know. The previous one, it was the 6th problem in the row, so perhaps it's not that hard, so I might actually take a look at it. We have basically values, formulas, and now let's see the problem. I don't know if I'm going to be able to see the problem correctly, as the webcam is right there. So basically there's a sphere with volume of 36 centimeters cube, and it's being melted and poured in a cylinder that's circular, with basically the I don't know, the length from the center till the end of a circumference equal that sphere. Find the height of a cylinder. So values have been written out here. Display these formulas and move from there. Formula right there, formula right here. You gotta understand the height. We have that value of the volume, so we plug in the formula of the volume. So we will get that r to the third power is this. 3 on top, 4 pi right there. Pi is going to be simplified. And what's this going to be? I don't know exactly. It's going to get calculated. We got a 9 right there, and that's 27. 9 times 3. And what number at the third power gives 27? That's 3. So the r is 3 exactly right here. And now we can work with the height using formula of a height. Yeah, you can't really see it, but anyways, you apply formula there and you get height, the height. Now we have a triangle with corner A. ABC is like a triangle that has all the lengths equal, and the segment AM is being constructed 2 centimeters length, which is perpendicular. This one's kind of like geek, and like I said, the webcam is really pertaining here, so I'm just gonna skip it mostly. Now the webcam's fine. Got a formulas. 2 centimeters right there. Distance between M and BC. Okay. We got a line. So that's like a formula, which I don't know if it's provided. Okay, whatever. We got this, we got that. That is another problem. That is a definite integral problem with t substitution. I mean, that is solvable, but I wish to skip on that right now. So now we got this probability. Okay, probability problem right here. Let's do it now. We have events and 3 volunteers from high school are participating. 5 volunteers from a college and 7 from a university. Randomly, a team is being formed of 10 volunteers. Out of all the volunteers aforementioned, find probability that in the team there will be at least 3 volunteers of each institution. So in the team we gotta have all the volunteers from high school because we're just 3. At least 3 from college, we're 5, so that's a possibility, and at least 3 from the university, which are like the biggest amount, 7. So this one we solve probability ourselves. We don't have probability, so we don't have to equal it with something. So just a normal formula and total number of cases. How do I get that? So basically n is total number of cases. We can work like this. So basically the order of his volunteers does not matter, so we're working with combinations, not arrangements. And we just think combinations from how many volunteers we take. So in total we have 3 plus 5 plus 7, that is 15 volunteers. So that's the number we write down on the C below, and we form a team of 10 volunteers, so 10 above. So that's our N. C1510. And to find out what the M is, we just need to write down the fucking circles, right? 10 circles. And write down all the possibilities, like pretty much the first circle. So basically, the order does not matter, just who's in the team, from what school and so on. So we can do all possibilities, like when and all of them there must be 3 from high school, and then we pop 5 from college, 2 from university, or 4 from university and 3 from college, all the possibilities. And we're just gonna solve that, yeah, plus it out, do the times, yeah, stuff like that. So C of like if I take high school square, it's gonna be C of 3. We're gonna check it out anyways. This stuff is not like the easiest stuff, but anyways, I can handle it. Events is being written out. N is gonna be that, which I said. So that is solved. You will have above 11 times 12 times 13 times 14 times 15, and below essentially 2 times 3 times 4 times 5, right? Simplified bloody webcam. It's too big. Why do I care about the webcam? 11, 3. That's after simplification, so we have that, which is going to be equal to, I don't know what, I can't see. So basically all the types of volunteers have been written out right here. And now all the possibilities. So first this, we can also, okay, so actually there are only 2 possibilities. I think I said once like from university to 2, but that's not good because we gotta have at least 3 from each institution. So these are the only 2 possibilities, which is good because you don't have to fuck around with 2,000 possibilities. So first thing, M is gonna be written out like C, I guess. So 3 and 2 right there, 3 and 3. Okay, so why 3 and 3? Because like I said, the order doesn't matter. We go C, and there are 3 basically volunteers of high school, and to take all of them 3. So that's that. We're gonna do times in the college. C below 5 because of 5 in the college, and you take 3. So work like that, and then you're gonna plus it out, and you're just gonna place in response. That's it. College just had C5 3 right there, and now the university there are C7 4 right there. Okay, so that's not an issue. We work with that. Now the second row plus we put it like there, C5 4 right there, and C7 3. Now we just solve that. Okay, so C3 3, that's just 1, right? And the rest of them we just need to solve because you don't really get out of nowhere like that. So that is 1. That's solved like that. That's right there, 7 3 exclamation 4 exclamation 1 right there, which we don't even need to write down as it's nothing pretty much. 1 exclamation mark still pretty much nothing, and so we got 3 4 right there. So right there, 4 times 5 on top divided by 2, and simplify, which is going to be 10. And on that thing, we have a 5, 6, 7 right there, and 2, 3. Simplify with a 6, and we have 35 right there. Now next up we have just 5 right there, and right there we have 35, as it is pretty much the same thing as that combination. So we got 10 plus 35 plus 5 times 35, much is that? I don't know. I guess you can take a common factor out here or stuff like that. 7, right? 7, and we got 50 right there. Why 50? I get that 35 is 7 times 5, right? Okay, so this is how it's done. You put a 7 up front, and we got 50 right there because 10 times 5. And then on the second thing, we got 7 right there. Plus 25 right there, right? Because it's 5 times 5. So it's going to be 7 times 75. So I know exactly that is like an easy approach. So what's that? That is 21 times 25. 21 times 25 right there. So simplify 21s. We're just going to get 25, and below 11 times 13, which is under 43. So this is what I have right here. Take a quick break. I'll be back. back. Now it's time to solve the terms problem. So previous one was probability, now we go with terms. Right, so we have formulas for terms of this one basically. You need this formula, boom. The formula below it, 1 over red, take q plus 1, already know it, so yeah, I'm good with that. Write down the fucking formula. So Cn0 right there. A is just gonna be what is in the parentheses, like right there. So basically formula. Okay, so if k plus 1 is 1, then k is 0. So put 0 right there. So basically I'm gonna read the condition I already yet. First term in this thing is 1024. Find the number of rational terms within this bitch. I don't know exactly how this is done, but I think for the most part like half of it I know it's done. Like this start, of course I knew I was done. Pop it like a formula and minus 0, and then lastly with a b term, which is 3 right here, equal all that with 1024, because that's equal to that. But right now we're working with the stuff, terms of the 2 and the 3. We're not touching the c, right? So what this guy did right here, 2 a power of n divided by 3, why that? Well, n minus 0 by just n, right? And if it's a 3 like that, in front of a square root, you can take it as a power. What's power? It's 1 divided by 3, because just the square root is 1 divided by 2, so this is 1 divided by 3. And when you plug that in with an n, it's going to be n divided by 3. And 3 power of 0 by just 1, but I don't know if it's going to write down as a 1. I don't know exactly how you play with the terms right here. Yeah, I don't think it's the case where you take to try to get the same base and then work with that. And divided by 3 right there. Okay. So get to that is 1024. So I guess the work is done. 3 power 0 is 1, so you work with a term that's equal to 1024. Okay. So Cn0, how much that would be? Was that ignored because it doesn't give any value, or just it's ignored part of the process? An exclamation mark divided by n minus 0 and then 0 right there. I think just ignore like that, I don't know. So 1024 just 2 power of 10. That's correct actually. So now I have the same exponent, so we can work with n divided by 3 equal of 10. So how much is that is going to be? Well, that'll be what, n equal 30, right? Yeah, so n is 30. So are we done already? I don't think it's that short. I don't know if this is mandatory. I don't know exactly how this case are solved. I think I'm gonna have to take a break to understand, or maybe no. So when you try to find the rational number of terms within this, k divided by 3, because that was that to the power, I guess. And so it gotta be something when you divide by 3 within the interval from 0 to 30, right? Okay, so you have 0, 3, 6, all the way to 90, right? Because 90 divided by 3 is going to be 30. 11 terms, huh? What? 11 terms. Why? Do you just write down what is dividable by the 3? Up until 30, right? Okay, so I guess this is how it's done. And if we count them all, we'll get 11. 11 rational terms. So this is how it's done. Now this equation is going to be solved, which is pretty much a bit hard, so I think I'm just going to skip that. This geometry one should be a bit harder with sine and stuff, so yeah, I'm just going to skip that and find a proper V8 video, which I think I already found. We have this guy. Shout out to Bivel Dragish. He's gonna actually this is the 9th grade exam, right? But I'm in 12th grade, so I think I need another video. Let me see this guy. So basically this guy, he's gonna solve it pretty fast or what? This is the 9th grade stuff, right? Man, this is the 9th grade. Alright, let me find some proper videos. Be back. Here is polynom stuff. So basically we have this polynom with x to third power. Show that x is equal to 2 is like a thing that works with this, and find the other ones. How is this called in English? Roots, right? Fucking roots. I don't know exactly how this one's done. I think we need to divide this by x minus 1 in order to get the x to the second power form. Then we do the quadratic right there, and so we're gonna get everything like that. And yeah, I need to like watch like 10 of this divisions of polynomials because they're fucked up. I watched like 3 so far, I know. So kind of remember them, but not that like fucking amazing. So let's see what's done. Right, sound that I need. And actually, perhaps this one's even easier than I thought, because it looks like this one doesn't need polynomial division. Just now we just plug in the 2, and after that what? That's it? We're gonna plug in 0 or stuff like that, I don't know. Plugging in the 2 is like really easy. Kids in kindergarten in China can do this. So we have 32 right there. 4 times 8. 16 times 4, that's 64. Plus 19 times 12, that's 48. Minus 6. 32 minus 64 plus 48 minus 6. And right there, 32. 32 plus 42, 64. So basically we have 0 right here. What, you have proved that P2 is equal to 0 or what? Yes, it's a root because it's equal to 0 when we plug it in. But we do also have a condition to find the other roots. So what to do with that? Division by x minus a. So I think we're gonna have to divide it by x minus 2, not x minus 1. I thought I'd just divide x minus 1 just to remove x to the third power thing so that you can solve a quadratic. But actually you could just solve it with a x term that you have. I mean, a, what is a? X is 2, or just gonna be x minus 2. Okay, so let me see, PA, what's... Let's get on with it. We got the polynom. X minus 2 like I fucking expected. So first thing first, like what I remember, you work with the fucking first term that you divide with. So the x, you divide by x minus 2, so you work with the x. And you divide basically 4x third power divided by x. So that's gonna be for x to the second power. Is it gonna be that? You're just gonna write that down in the results. Then you're gonna multiply that, and then you're gonna divide and so on. I barely remember it. 4x to the second power. Okay, so I got that right. Okay, so now we just have to multiply the value with the whole thing we are dividing with, so x minus 2. So we will have 4x third power minus basically 8x to the second power. So pop that to the left. So pretty much looks like so far I can remember it. Now just divide. 4x third power minus 4x third power, that's just nothing, you don't write it down. And there you gotta watch out. You got 2 minuses, so it's gonna be plus. It's gonna be minus 16 plus 8. How much is that? Minus 8. So you're just gonna get minus 8x to the second power, and you're gonna plug that in. And then you write down the term that is next, 19x. Okay, so done that. Now after we have plugged in the 19x, we actually don't work with 19x right now like before. I think we need to divide with the first term, right? So minus 8x to the second power divided by x. How much is that going to be? That will be minus 8x. So write that down next to 4x to the second power. I'm going to do the same process, minus 8x times all that, plug that in, divide again. Yeah, I think I know it. I'm acing it. Actually write down the 6 right there, but okay. Are you actually going to work with a 6 right there? 8x. Okay, so we're good right now. Now if we multiply, it's going to be 8x to the second power with minus, and then minus 8x times minus 2, that will be positive 16x. So plug that in. Do the division again, so we're going to get 3x minus 6 in the next step, and work just the same. 3x minus 6, and now we have that. 3x divided by 3, how much is that? That is 3. Plus 3, pop it right there. Do the same process, and you're gonna get nothing to the left when you divide. So this is the result. Solve quadratic. That's it. 4x to the second power minus 8x plus 3, pop it equal to 0. It's all good, canonical. 3x minus 6 right there, nothing is there. Okay, so what you need to do now, the result, when you write down terms, factors, I don't know, it needs to be like in parentheses, like the results. You don't write down just x1 is that, x2 is that. You just write down first thing, so x minus 2, and then you write down x minus what you get first x1 value, and then x minus x second value. That's like what I remember. So I see that this is what we have so far. We're just gonna expand that quadratic, right? The parentheses right there. So we're gonna work with that. X minus 2 right there. So working with quadratic equal to 0. We cannot just leave it like that. Delta will be 64 minus 60 times 3, which is 48. So that's just 16, so square root of delta is 4. Then we solve x1 and x2, so on and so on. Okay, so we got that, 8 minus 4 divided by 8, how much is that? That is 4 divided by 8. That is 1 divided by 2, or 0.5. And now the next thing is that 12 divided by 8. How much is that? Well, that's 6 divided by 4, and then again 3 divided by 2, right? Yeah, 3 divided by 2. We got that. Now we just plug the values in like just I aforementioned. Let's get this done. What, that's it? You're moving on to the next? You're not gonna show how it's written? I guess. Okay, so guess what? We're doing exactly the same thing. Here, it's literally in the condition. You see this px polynomial, you just have to divide it by x minus 2. And we're gonna do that. You remember the algorithm? I'm gonna do it for practice sake and move on from there. This is just some theoretical bullshit. I'm just not gonna go into it. Just do the division Let's get on with it. So actually she starts with 2. P2. Why again P2? I thought we just have to do the division. Why do you have to do that? Anyway. Like, what do you get by getting P2? Random Euclid of 0 or what? Anyway, we have this. So 2 times 8 right there. 16 plus 4 minus 10. And that is what? We got a 1 right there, okay. 20 minus 10 by standard, so we got 11. So P2 is 11. So that is our x. What? That's. Okay, so actually, yeah, I think that one was a lot easier. I think I did do stuff like that before. I forgot that the process right there is way easier. And anyway, just got 11 right there. Now we're gonna do one of a parameter that's a right there. So I know exactly how this one's done, I guess. Okay, so you got the -1 of the root of this polynomial, but you gotta understand the values of a, the small a right here, in the polynomial. To do that, you just plug in the -1 in the polynomial and equal it to 0, and you're gonna get a. It's easy as cake. So plug it in. Come on. B. So that's the condition right there. And then you just work it. That to the third power. It's not gonna get positive because, okay, third power is not gonna get positive. Second power is gonna get positive. Now that's everything plugged in. Now that's -1 right there. And right there we have +1 in the parenthesis after the power has been applied, but then we have a minus again, so -1 plus, actually not plus because you got minus right there, minus a plus 2 plus 1 equal to 0 right there. Right there, man. So that is being simplified. So get -1 minus a plus 2 equal to 0. Well, -2. Hold up. You have switched the sign of a, but you have to also switch the sign of 2, right? It's in the parentheses. She's gonna correct it, right? I don't know. Yeah, I know better mathematics than them. We got -a, 3, so it's gonna be -3. Perhaps she's not gonna correct it because she doesn't have a lot of viewers in the chat to correct her. Okay, so she actually wants to do a verification by herself. I don't know if she did this mistake on purpose just to prove that verification works sometimes, or is necessary sometimes. Okay, so plug in -1 right here. So plug it in, knowing that a is -3 now. So when is a -3 is going to be -3 -2, so that's -5 right there. Plug in -1 right there, and if it's all correct, it should equal to 0. But it's not, because the parentheses and the signs have not been correctly adjusted. So we'll get -1 again. Hold up. -1 again. +5 and +1. Okay, so that's, guess what? That is not correct. You fucked up. So she checks now, and she will understand that she fucked up on the sign. There we go. Now you're all good. So it's gonna be -2 plus 1. So -a is gonna be -1. So a is gonna be 1. So now, before that's, instead of -5 here, it's gonna be -1. So now I work with that, and now it works. So at least she understood that she fucked up. Okay, now this one's quite easy. I know how to do this at midnight. It's so easy. 5th graders can do it. In Pakistan. So we got the polynomial again. Find values of a. Knowing that polynomial is divisible with qx, which is x minus 2. This one, like how do you do it? X minus 2 equals 0. So x is going to be 2. Plug in the p2. And then equal to 0. And you're going to find the a value. That is it. This is the easiest stuff on earth. Okay, it's not the easiest stuff on earth, but you know, if you know the algorithm, it's going to be damn easy. P2 right there. So we got P2. Work with P2. She doesn't even write down x minus 2 equals 0 and stuff like that. Like, come on, why do you need this px, 3 dots, qx? 3 dots means that it's divisible, like 3 dots in vertical line. I don't need that. It's not mandatory. Okay, now just solve this. Got 8 minus 16 right there, minus 2a minus 4 equal to 0. Okay, now minus 2a right there is going to be equal with what numbers? If you move everything to the right, the sign changes, so we have 20 positive minus negative 8. So it's going to be 12 right there to the right. So 8 is going to be minus 6 once the division is completed. So 8 is minus 6, that's the response. And I think you don't need to write down like the whole polynomial with the a swapped. Just have to write down a equal minus 6. So yeah, that's that. That's simple. Next thing. The ones where you have to divide like polynomials, like in the fraction form, that's way harder. This one's like cake. Okay, so we have this. Okay, now this one. Once again, polynomial. And we gotta understand the rest values when this is divided by x to the second power minus 1. In order to solve this, I don't think we need to divide it in the fraction form. Just do x to the second power minus 1 equal to 0. So that is going to be x is equal with 1 or minus 1. Then swap that in. I guess, or maybe not. Let's see this one. I can only guess on this one. I'm never 100% sure. Okay. Skip a bit. Okay, so actually I have to do it like this. Okay, so this is harder, but I do remember the algorithm. So, first thing that I do, x to the third power divided by x to the second power is going to be x. Plug that in the results section, and then just multiply everything with the finger on top, right down there, division and so on. So it's going to be right there, x to the third power to the left, minus x, right? That should be that. X to the third power, minus x. Okay, so this is that. Now here's quite strange because usually you get values that are like exactly the same in terms of the powers of the x. So here I'll have 2x to the second power plus x. If we take into account the minuses, x to the power 3 minus x to the power 3, which is nothing. And we work that. How much is that going to be? Minus 2x to the second power plus x, which you're going to write down like that, right? What else are you gonna do? It's not division, it's just negative. I mean positive, plus. Okay, so she's gonna move stuff a bit because there's too little space, I guess. Okay, so this is how it's done. Okay, so this is how it's done actually. When you get stuff like this, you have to divide with the same stuff though. X to the second power stuff minus x to the second power stuff. So we have an x stuff minus x, so we have to divide it with x stuff. So that is not available here. It is skipped. So just plug in ourselves. We can do that. We plug in plus 0x right there. And pop the minus x right there. And it's gonna be 0x plus x. So how much is that? X. Right? And then you just work from there. And for minus 2x to the second power, just bring it down. And you work like that, right? Actually, plus 0x to the second power, if you don't get anything with that, so we pop that. Yeah, I forgot about this zero stuff, addition. So yeah, that's a bit more geek stuff, but you know, I can handle it, so let's get it. Pop a minus x right there, plus 16 right there. I mean, plus 16, we don't touch that. So that's nothing. What's that? That will be minus 2x to the second power. And that will be plus x. Okay, plus 16 right there. So now we can work just like before. Minus 2x to the second power divided by x to the second power. That is just minus 2. So plug that in. And then it's going to multiply that. Plug the minus 2. So minus 2 x to the second power right there. Plus 2. Minus 2 times minus 1, that's plus 2. So you pop that below the plus 16. And you have to have a value below the x also, so you pop a plus 0x right there. And you're gonna be good like that. Okay, so x minus 0x, how much is that? X. And 16 minus 2, that's 14. So it's gonna be x plus 14 right there. Okay, we got that. We have x plus 14. Now we work with that once again. So x divided by x to the second power. Can we actually do that? How much is that going to be? 1 divided by x or what? What is this tricky stuff? Okay, so we actually cannot continue if we get here. So this is the rest. We don't take a look at the value. We just need the rest based on the condition. The leftover, whatever it's called. The r of x, so x plus 14. You write that down to the response and you're good like that. X plus 14 right there. Okay, so I don't know what she's explaining, but anyways. Now we have a free row matrix. Free row and column matrix. And we have to understand if this is divisible by x minus 2. In order for it to be divisible, it needs to be equal to 0 when we plug that in. So basically, we just do x minus 2 equal to 0, so x is 2. Instead of x, we plug in 2. And we just solve it. You just solve that as divisible like that. So you just write down the last two, the first two rows. X 3 0. It's gonna be shown how it's written out, and then you're just gonna multiply diagonally, plus, then negative. It's gonna be shown out. I know how it is, but it's a bit long to explain. So yeah, just plug it in. The 2. Yeah, bank. I don't care about that. Straight talk, man. Okay, so she actually just works with x. She does not plug in the 2. I don't know why. To be honest, I think I did like 2 exercises in my life that are like this, so can't really judge if she's doing wrong. Perhaps it's correct. The correct approach. Anyways, you just multiply diagonally. Banner is going to have minus 1 times 6 times 0, which is going to be 0. And lastly, plus 2x times 3 times 3. How much is that? That is 18x. So that is that. And that is that. She does not plug it in like fast. This is the whole form. Then we pop a minus. When we go to the next side of a diagonal, 0, we get nothing right there. Then we get negative again. It's going to be 3 times 6 times x. And then negative again. This is how it's done, but usually I just pop a minus when I switch the diagonal side. Then open a parenthesis and do the plus in there. That's also the correct variant, but anyways, this is also doable. So we have x minus 2, all of the expression times 3 times minus 1, so you have to put the x minus 2 in the parentheses, just so. Okay, so now work with that. We will have x to the second power times x minus 2 right there. That's a 0 right there. Right there we have plus 18x in continuation. Plus 18x, right? That is nothing but 0. That's 18x. Minus 18x right there, so we're just gonna cancel it out right now, right? She doesn't want to cancel it out right now. So we have 3 times minus 1, which is 3. And that's not 3, that's minus 3, and it's with many signs, whatever. Let me see how this is done. 3 right there, and x minus 2y. So basically we have 2 minus signs. So I have a minus and a minus, and it gets just plus 3, and then we have x minus 2. Okay, so this is how it's done. And now next up we have x to the third power minus 2x to the second power. Those plus 18x minus 18x, but just nothing. And next up plus 3x minus 6, right? Okay, so we got that. That's it, like, we're just gonna plug in the 2, right? Now, the powers are good. Okay, so we gotta be 0. Okay, so what now? P of 2, like I said, x minus 2 equals 0, so is 2, x is 2. Plug it in, and that is all equal to 0. It has to be, in order for us to show that this is divisible. So we're gonna have 8 minus 8 looks like, and then plus 6 minus 6, so it's all 0. It is 0. It is correct. It is genius. I have no issue. CTD, basically that's like what we had to demonstrate. Okay, so now we got this. This one's like a bit longer in terms of condition. We got polynom x to 4th power and so on with parameter m, and this one is divisible by the binom x plus 3. Find values of m, knowing that the values of the rest okay, so find the values of m and the rest for the division by x to the second power plus 3. Okay, so this is how it's done here. Okay, so we got this whole expression right here. Let's see. Well, okay, so is divisible by x plus 3, the binom. So what we need to do is just basically plug in 3, minus 3, because x plus 3 is gonna equal 0. So x is gonna be minus 3, and then we have the b minus 3 calculation. Solve that. Plug in the minus 3 instead of x, and then we're gonna get that. And then somehow we're gonna get the m by equaling with 0, or actually no, because anyways, we'll see. Sounds a bit hard. Like, do I actually need to divide all of this by x to the second power plus 3? Do I actually need to do that? How are we gonna do that? We got the m right there. God damn it. Let me see. Yeah, that's right there. X plus 3 right there. So p is minus 3. Yeah, p is minus 3. So now we're just plugging in the minus 3. Okay, I expected that. That is a reasonable solution outcome. Plug in the minus 3. We have minus 3 to the second power right there. Minus 3 right there, plus 3. Okay. So that is equal to 0. Okay. So fourth power is positive power, so that's gonna be positive. What's 3 of power 4 is what? 81? Yeah, I got it. And then third power is minus 27. So minus 27m minus 27. This is what I have. She's just gonna plug in the parentheses for now, it's no issue. And then we have plus 18, and then we have minus 21 plus 3 equal of 0. This is what we have. Now we just remove the parentheses. Minus 21 plus 3 is minus 18, so we can just scrap that, right? So we gotta work with this, right? 81 minus 27m minus 27 equal with, I thought, bitch, minus 27, not minus 1. 0. So we got that. Now, minus 27m, this is just quadratic, right? Okay, it's not quadratic, it's, because we don't have any m to the second power and stuff. So we have a unknown value to the left, right? Minus 27m. Move everything that is non-m to the right. So it's going to be 27 minus 81 to the right there. Okay, so we're going to plug that in. let me check something out, guys. Gonna be back.